This week, we'll look at how to control the size of a figure in Matplotlib, looking at the American Meteorological Society's figure submission standards so that your next journal submission goes through without a hitch. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week I thought we would look at submitting figures to a journal, and there are many things to talk about when doing this, but the first one that gets so commonly overlooked is figure sizing. You might make your figure and tweak all of your font sizes, tweak the tick marks, have everything just like you want it, but then it has to be resized to fit the journal that you're submitting to, and suddenly everything goes sideways very quickly. So it's best to start looking at those things immediately when you're going to make your figure. Generally, my process has been I draw on a piece of paper what I want my figure to look like, what story I'm trying to tell with it, and then I start coding up that figure from the beginning, knowing what size it has to be for journal submission. So here I've pulled up the guidelines on figure size from the American Meteorological Society. So you can see they have 1 column, 2/3, 2 column, and more than 2 column sizes specified. These are shown in picas, inches, and centimeters. Depending on how you have your Matplotlib RC file configured, your default unit might be different, but by default it's going to be inches. And at picas, in case you're wondering, they have a conversion down there, but it's from typography. A pica is 12 points, or approximately 1/6 of an inch. Another thing to consider, and a very important one, is the color space, though we're not going to talk about that in this video, but RGB versus CMYK are very different, and CMYK, which is what journals are printed in, can't replicate some RGB colors, but the RGB colors are generally going to be the more vibrant things that you want to use. So that's something worth reading about, and maybe we'll talk about it in the future. But the other thing is how many points per inch or dots per inch we have in our figure. You see they recommend for monochrome line art 1000 to 1200 ppi, for combinations 600 to 900, and for halftones, no lettering or anything like that, about 300. It's also worth knowing that these are all for raster images. If you're using vector images, which I highly recommend because they scale very easily but aren't the best if you've got a lot of data points, it doesn't matter because they don't have a dots per inch or pixels per inch value. But we're going to stick with raster images for now. So I'm going to make a monochrome figure, let's say 1100 dots per inch. And going back down to our size table, I'm going to make this a 1 column figure, which would be 3.2 inches. So first, let's just do our imports and make some fake data. I'm going to import matplotlib.pyplot as plt, import numpy as mp, and I'm going to use the matplotlib inline magic. Okay, so now we need to make some fake data. I'm going to use numpy's array range function for 256 values. Then for y, I'm going to make it equal to x, so a line with a unity slope. And then add in some random noise of size 256 elements and multiply it by 10 so it's a little more apparent on my figure. Again, you'd be using your real data here, obviously, or making whatever sort of fake data you like. I just like having a little bit of random noise so that these figures look a little bit more believable. All right. So now we're going to create our figure and our axis. I'm going to use plot.subplots. And I'm going to call ax.plot, x, y. And since this is going to be a black and white figure, as they are much less expensive to produce, we will set the line color to be black. So a few things become apparent instantly. One, I could start adding labels. I mean, maybe we will. And maybe even changing the font size on those, but when I save it, it's not going to look how I think, especially once I adjust the size. Okay, So I'm going to do a subtitle of important data. I'm going to set the X label to be the independent thing. I'm going to set the Y label to be the dependent thing. And I'm going to save the figure as important figure.png. So now we run that and we see, okay, maybe I want to increase some font sizes and start modifying this a little bit to look more clear. But before I do that, I'm going to go ahead and change the figure size, and let's see what impact that has. So if we go back and look at our guidelines for a one-column figure, I'm going to shoot for 3.2 inches final width. Up here in my subplots, though you can set the figure size later, but we'll just do it when we're creating the figure here. I'm going to specify fig size. In this case, I want a square plot of 3.2 by 3.2. Okay. Well, this may or may not be 3.2 inches depending on your display settings or when you print it on your printer settings, but we at least see that we've got something that looks like a square figure now. And I'm probably not going to need to change my font sizes because, well, now that it's smaller, this looks a little more right to me. Figure making is very subjective. But the default dots per inch is set relatively low. Remember, if we go back and look at the guidelines, for a monochrome line art with text, we're looking at 1,000 to 1,200 ppi. So I'm going to set my DPI to be 1,100, right in the middle of that range. Okay, well now it displays on my screen much larger because my screen does not have 1,100 dots per inch. It's roughly that, almost all the way across, in fact. And so this shows up much larger on my screen. But if I go into my File Explorer and look at the details, we can see this is 3,520 by 3,520 pixels. If you take 1,100 and multiply by 3.2, that's exactly the number of pixels we would expect. All right, so let's see what else we can do to this figure. One common thing to do is going to be to use tight layout to utilize as much of the white space in the figure canvas as we can. And we see something interesting has happened now. I'm going to go ahead and open this figure, and we see that, well, important data has got moved, our subtitle. It's now down in the figure. If we remove tight layout again and remake the figure, notice that, well, there's been some artifacts here that we didn't catch the first time. Our y-axis label is gone. And here we're starting to cut off things like the bottom of the G. So using tight layout is a way to say everything has to fit in that number of pixels. And it does result in things getting moved around quite a bit. So let's turn that back on. Let it finish and open the figure again. All right, so we have both of the labels. The G is not cut off, but to get that to happen, this subtitle had to get squished down. Really, I would say maybe you don't need a title, or you can just use ax.text to put a title on wherever you'd like. Though generally I haven't titled my journal figures, I just describe in the caption what's going on here. But those are a few tips that really make a big difference when you go to submit to a journal. The editors really enjoy working with your manuscript and will do a lot to help you if you followed the guidelines. So read the guidelines, try to submit things that have the right resolution and the right size the first time. It's not that hard to do as long as you think about it from the moment that you start making your figure. If you get a very complicated multi-panel figure made and then go back and try to squish it into a certain fig size, it's certainly going to be a lot more difficult. So I hope that you found this useful, and I'll see you on next week's MetPy Monday.